All right, guys, I'm back with page 260 to 263. As you can see behind me, I've switched the board a little bit. Necessity is still the mother of invention. But in these next 4 pages, we're going to be talking about how redesigning a product occurs and how, yes, necessity is the mother of invention, but the necessity for change and why things have to develop a little bit differently. Like washing boards then turned into this manual washing machine, which then turned into the washing machine you know today. All right, so active reading on here, it says to underline the sentences that describe how technology affects our lives. We've already been talking about that for so much that I'm not going to go ahead and do that one. But if you want to underline, then go right ahead. So the captions say, centuries ago, many people washed their clothes on rocks in a river. The invention of the washboard allowed people to wash their clothes at home. So doing it on a rock in a river, you think your clothes are going to last very long? Probably not, because you're bashing them on the rocks and you're rubbing on the rocks. So you really wore holes in things probably pretty quick. So then they got to a washboard, and that washboard worked pretty well. If you look in your book, they should have an example of it actually being used in the wash tub itself. Over the past 150 years, oh wait, nope, sorry, wrong one. I'll go to the other one, the little bubble on the little lower. The washboard helped making washing clothes easier, but it was still hard work. You still got to go wash with soap. But in the 1800s, engineers designed machines that could be filled with water and had a hand crank wringer to wash the clothes. So if you look in your book, the little thing that's above it, this thing right here, there's 2 little rollers there, and you would put your wash in here with the soap, swish it around, and then wring it through here, and that would wash it. Then you'd rinse it out and wring it through here to get most of the water out, like a rinse cycle. The wringer made getting the water out of the clothes much easier. And then finally, over the past 150 years, engineers have improved washing machines. Even today, new washers are being designed to work faster and more efficiently. My washer at home, we got new ones a couple years ago, and they stack on top of each other, which is space saver. That's kind of nice. And they both front load, so instead of being you open the lid and put it in the top, now it just goes right in the front. It also doesn't have an agitator. There's a little round thing in the older models that would turn and agitate and move the clothes around. Well, that also tends to rip holes in things or things get caught around it. So now with no going this direction, like they do in laundromats and things, you don't have to worry about that. Go ahead and turn the page 262, 263. Imagine you're part of a team that is designing a new washing machine. What is the first thing your team should do? How would you know when your new design is complete? Read to find out. So on these pages, guys, this is talking about how to redesign. So once you come up with your first design, maybe you try it out, and then you redesign it to make it better. Or you look at another product, like this one right here, and want to change it into something newer. So how do you do that? Well, it says here in the book, some engineered devices meet human needs better than others. Engineers study and test engineered devices and find ways to improve them. For example, engineers who work on washing machines may want to improve how much it costs to operate their washers. They may measure how much electricity and water their washer machines use. They may also measure how much detergent it takes to clean the clothes using their machines. Engineers use math to compare the benefits of alternate designs. They draw diagrams of improved engineering devices. Engineers use these diagrams to build models. Models allow them to test their designs. Engineers keep good records of their work so that others can build their designs as well, or even improve on them. So now looking at the page, you see the 2 bar graphs on page 262. It says the bar graphs show one way engineers can share information with each other. So these are a couple of little bar graphs. The first one shows how washing machine, the designs are A, B, C, and D. The first one talks about its water efficiency, so how much water it needs to use to complete its cycle. The second one is about its cycle efficiency, so how many minutes it takes to wash the clothes effectively. So then on page 263, we want you to go ahead and design and analyze your own graph. Now, there are some key points to making a graph. We've done this before in class, so this is kind of your test to see how you do in doing it yourself with all of the information. It says use the table to make a bar graph showing the running cost per year of the 4 washing machine designs. So if we're doing the cost, then we care mostly about money, right? So looking at the data, try to figure out which of those columns of data you're going to be using. Are you going to use water use, liters per wash cycle, cycle time, minutes per wash cycle, or running cost, dollars per year? So try to figure that out, make a graph about it, and then check the next video kind of for the results to your graph to see if you got it or not.